So, hello everyone. Today we are discussing about the Ptsp seminar for mid-do properties of autocorrelation and cross correlation. Second year Ptsp for second mid seminar topic here it is introduction of autocorrelation and cross correlation for tools and for tools in signals analysis and static process. Here the autocorrelation and cross correlation are the two major key points for the signal analysis and the stochastic processes. They measure similarity between the signals and their shifted versions. They usually their work is something like similarities between and shifted versions in signals. Definition for autocorrelation function is represented as SAF and measures the similarities between signals and time shifted versions. Here the autocorrelation it simply does takes to signals and it will analysis the similarities between signals and it also analyzes the time shifted versions of the signals easily. It is mathematically represented as Rx of tau and integral of x of t to x of t plus tau dt. And definition of cross correlation. Here the cross correlation function is represented as CCF measures the similarity between two different functions. It will measures the only similarities between two different functions. It is also represented by cross sections like rxy. Here we can see the rxx. Here we can see rxy means cross xy. It is both different variables. Here rxy of tau equal to integral x of t to y of t plus tau dt. Here is the cross correlation. It will measures the differences between two different signals. Basic properties. Here we can see basic properties. There are so many properties in both autocorrelation and cross correlation. We are discussing the major three properties, basic properties. First one, even function. It is the first property is even function. Even function means rxs of tau is equal to rxs of minus tau. It is even because the autocorrelation only exists in even. If it is a minus also it is equal to plus it is symmetric signal. Here the autocorrelation, the maximum value of the signal lies between origin. It is tau equal to 0. Energy of signals. Energy of signal is rxs equal to 0. Then the total signal energy. Here we can see the here we saw that maximum value of autocorrelation lies in between the t equal to 0. Then it is the energy also lies in between the origin total signal energy. Autocorrelation energy signal. Here we can say autocorrelation energy signal for energy signal represented at rxs equal to rxs of 0 equal to integration of x of t to x of t whole square dt equal to ex and rxs of tau equal to greater than rxs of 0. Here we previously discussed that the maximum energy of the signal lies in between t equal to 0. Here is the same point. If any value of rxs of tau is any value, it will be lesser than or equal to rxs of 0. Autocorrelation of power signals. For power signals, rxs of tau equal to limit tends to infinity and 1 by 2 t in integral of x of t dt. It is the expression. And rxs of 0 equal to average power of the signal. Because because the majority of the signal energy is lies between the origin, then it r axis of 0 is the average of the signal, because the most of the energy of the signal lies in between 0 origin only. Symmetrical property autocorrelation is and we can discuss in that it is a symmetric property, because r axis of tau is exactly equal to r axis of minus tau. It is one of the property, symmetry property. And maximum value, here previously we discussed about it. The maximum value of the signal is lies in between the origin of the signal. Here previously we were also discussed it. R axis of tau is lesser than R axis of 0. Here we can it is the majority of signal lies in between origin. It will be the average of the signal lies between the origin. Quasar-Schwarz inequality. It is an important expression. Rxy of tau equal square is lesser than r axis of 0, and it is defines the upper bounded for the cross correlation. It is the upper bounded for the cross correlation. It is an example of cross correlation because it has both x term and y term also. Time shift. If y of t equal to x of t minus tau, then rxy of tau equal to r axis of tau minus t naught. Shows the how correlation shift with the delay. Here if y of t equal to x of t minus tau, then rxy of tau equal to rx's, because it simply tells about time shift property. How the cross correlation is related to autocorrelation. Shows how correlation shift with delay time function. Conjugate symmetry for a complex signal. Conjugate symmetry for a complex signal. R axis of tau is equal to R axis of minus tau star means conjugate. Here it is not having any symmetrical property. It is just reverse. Conjugate means it's symmetrical. It is a kind of symmetrical only, but conjugate. Here we can flip the signal, then it will get conjugate, and it will be equal to the minus tau signal. Cross correlation. Cross correlation. It is property, one of the property, conjugate signal. Relation between energy spectral density. In this energy spectral density, by Van Kirchhoff theory, x of f is equal to the Fourier of r axis of tau when it is applied to autocorrelation and power spectrum and Fourier transform pairs. It is applied to autocorrelation and power spectrum and r Fourier transform pairs. Here some of the example of this relation between spectral density. First, it is also easy. Here we can we can substitute the formula and we can get the answer. This both are easy only. Cross correlation property. Rxy of tau is equal to Rxy of minus tau, and Rxy of tau is lesser than R axis of 0 and Ry of 0. The maximum value indicates the strongest similarity. Applications. Here, cross correlation applications. Signal detection. Here the signal is present or not. It will detect the signals, whether they, which kind of signals are there and what type of signals are there. System identification. It is also integrated in the system, and it will work through the system identification. Radar and communication system. It is simply we can see in militaries and some of the there higher in the higher altitudes there are some of the radars are there, because in these oceans and higher altitudes there are no such a speed communication. Here the through radars only all are get communicated, and this is called radar communication system. Time delay estimation. By this autocorrelation cross correlation we can estimate the time delay and time delay estimation also. Discrete time correlation. Here we can in the previous we saw the continuous signal. Here for the discrete signal, autocorrelation for discrete signal are rxs of k equal to summation of x of n and x of n plus 1. Where the discrete are so many points are there, we can use the summation. Cross correlation rxy of k and summation of x of n to y of n plus 1. Here this formula is little bit similar only. We can exchange the x and y variables. Graphical explanation summary. Okay, with the summary we can end the session. Autocorrelation measure the self similarity, and cross correlation. Autocorrelation measure the self similarity, means in the same signal we can measure the same signal similarities. What are the differences between same signal, like symmetrical or not, time shift, delay, and so much. Cross correlation measure the similarity between signals. Cross correlation means it will cross check between two signals and measure the similarities. What are the differences are there related to energy and power and frequency domain. These both are related to energy domain, power domain, and frequency domain. So with this I will end the session. These are some of the references I have referred for this seminar. Thank you all.